Hello guys, so welcome to Electro King. So today we have LG. This is a slim type. So let's check. The problem of this one, it has no power. So let's check what happened to this CRT TV. Okay, so we're gonna be doing the voltage check first. Let's see. We're going to connect the wire to the outlet, and let's see what do we have. We are going to check B plus, with which is usually it has to be 115 volts. So let's see what's gonna happen when we power on. So we have standby, and then when we push the power, oh, okay, I think we have a B plus, but it's very high. And then let's check it again. So when we push the power, it's very high. See, I'm sorry, I got 132 volts, which is not good. So that's why it's shutting down to protect the voltage. I mean, to protect the rest of the circuit from over voltage. So this is most common in LG. Now what we have to do is we're going to check what's the cause of this problem. So most of the time, it's the feedback circuit or the sampling circuit. So sampling circuit consists of resistor, capacitor, um, so it's resistor, capacitor, this optocoupler, which is basically the one who's sending the signal into our primary voltage. So we are going to check these components. Most of the time it's the resistor. These are this resistor over here is changing the resistance into, sometimes it's open or high resistance. So if this resistor change its value or it's open, the effect on our B plus, it's gonna go high. That's the reason why um, the TV goes to shut down, because it has to protect the entire circuit. So circuit's good because it has its own protection. And you see this transistor. So this transistor is the protect circuit. So this is the mechanism or the circuit that's shutting down the TV once it's detect that the B plus is over voltage. And what do we have here? So we also have TL431. So TL431 is the it's adjustable Zener diode. So we have TL431. If TL431 is open, it's gonna cause for the circuit for the B plus to go high. We also have here, this is the photocoupler of the secondary, which is connected to the sampling circuit. So this one isolates the secondary and the primary, but this is the main feedback. So yeah, here so what do I got here? So I removed the solder of the resistor for me to test, because this is the main suspect. So as I check the value of the resistor, I realized that the resistor is open. So meaning to say there's no resistance at all. So see, you see that? Okay, so it's not working. So I just remove the resistor in the circuit, and I also double check if it's still working, but it seems like that this resistor is not working anymore, so it's open. uh, this is 27k resistor. It's very small, but it's used as a sampling circuit. So if this resistor is open, um, it's gonna cause the B plus to go high, because remember, there's no voltage divider. The voltage divider seems to be open, so there's no electrical current that flows in this resistor anymore because it's open. So since I don't have 27 ohms, I mean 27k ohms, I have these two resistor which I combine into series, and we are going to use this as a replacement for that resistor. And I also checked this capacitor. It seems that this capacitor, I mean some of the capacitors are not good anymore, because the pin are, it's open, it's corroded. So here, as you can see, the remaining pin of the capacitor is not working anymore. It's open. And I also checked that some of the small capacitor, they are exploded. So we're going to change this as well. Okay, so this capacitor over here, the small one, we're gonna check it, and we are going to place the resistor into this respective place. So here, let me just put this resistor. So here, guys, so we just put the resistor in the circuit, and we are going to check the voltage. I still have the capacitor, but it's not connected into the circuit, but it's okay because it's not in that section. So you're just going to test if there's B plus, if the B plus is normal, and then if the B plus is normal, then we're gonna replace the rest of the components, which is capacitor. So we are going to plug in, and we place our test lead into the secondary capacitor. Oh, okay, so it looks like it's working now. I have 115 volts reading on my tester. I'm sorry, because the test multimeter is not seeing on the screen, but I'm gonna show you. Alright, so I'm gonna show you now the screen of the TV, because I got B plus, that it seems to be working now. There you go, you have a channel. Alright, so it seems to be alright now. So that's how you troubleshoot the LG TV Slim Flat.